Hello guys, welcome to our class for today. This is Number My Science Tutors Online, and today the topic we are going to be looking at is couple, torque, center of gravity, and stability of objects. We've started discussing moments, equilibrium of bodies or equilibrium of objects. So today we'll be still continuing with that class, but for today we'll be looking at couple, torque, center of gravity, and stability of objects. So this is Normal Math Science Tutors Online, and I remain on top of Michael. You are welcome to our class. Please get your writing materials ready so that we can go straight to our class. But before then, if you have not subscribed to this channel, please just subscribe. Click on the subscribe button, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also, if you are a returning subscriber or you have always been visiting our site or our channel, please give us a like, give us a thumbs up, also give us a positive comment so that we'll continue to bring out quality videos for your learning. You can reach us via the WhatsApp number that's showing right on your screen. So if you are ready for the class, please let us go straight to the class for today. Okay, so we are looking at the moment of a couple, and we are going to talk about torque and couple. So a couple is a pair of equal and opposite forces whose line of action does not meet but brings about a turning effect. Okay, their line of action does not meet but brings about a turning effect. So this is just a diagram to represent a couple. So these are two equal and opposite forces, P and P. They are two equal and opposite forces. You know that once these two forces start to act on this circular body, they will produce a turning effect. The same thing too with this is force, this is a force. So if they start to act, they will cause a turning effect on this particular object. So that is what a couple does. So a couple is a pair of equal and opposite forces whose line of action does not meet but brings about a turning effect. So the moment of a couple is the product of one of the force and the perpendicular distance between the lines of action of the two forces. And this moment of a couple is called a torque. The moment of a couple is called a torque. So you can take note of that. These are like objective questions that can come across in your examination. The moment of a couple is called a torque. Okay, so just as I've said, moment of a couple is equals to the product of the force P times D. Now for a circular object, you know that this distance is 2 of radius. So you can either say the force times diameter, which is D, or force times 2 radius. You know that 1 diameter is equals to 2 radius, so you can have this. So that's okay. So you can have that. Then for this particular drawing, the moment of the force or the moment of the couple is equals to 1 of the force times this perpendicular distance. Okay, so and that is force times A, right? So this couple is actually applied like when you want to turn the head of your tap, right? When you turn the head of your tap, it is applied in turning the head of a tap, or when you are turning your steering. So when you turn the head of a tap, it causes a turning effect. The same thing when you turn your steering wheel of your vehicle, it results to a turning effect. So that is the effect of a couple. And as I've said, the moment of a couple is called the torque. Okay, so this is the introduction to couple and torque. Okay, so I hope that one is clear. So this is just like a question for your check. The two forces of magnitude 25 Newton act in opposite directions at the opposite ends of a circular ring. If the diameter of the ring is 65 centimeter, calculate the magnitude of the couple acting on the ring. Okay, so just as I've said, yeah, they're giving you the force to be equal to, force is given to you to be 25 Newton, and then the diameter of the ring is equals to 65 centimeter. Okay, so you convert this to meters by dividing by 100, so that will give you 0.65 meters. Okay, so the moment is equals to force times the diameter. If it is radius that is given to you, you multiply the radius by 2. So that will be 25 now, multiplied by 0.65. Okay, so when you multiply that out, it will give you, by the time you multiply that out, you are going to have 16.25 Newton meters. 16.25 Newton meters. All right, so that is how to solve problems on couple. That is how to solve problems on couple. Okay, so I hope that is relatively simple. In case you see any questions on couple, there is no other fast and hard rules about it. I just have to go about it. All right, so let's go on to center of gravity and stability of objects. Okay, so center of gravity. The center of gravity of a body is the point through which the line of action of the weight of the body always passes, irrespective of the position of the body. Okay, so the center of gravity is the point where the weight of a body passes through, no matter the position of the body. Or center of gravity is also the point at which the entire mass of a body appears to be concentrated. So for some regular shapes that we know, you can actually get their center of gravity from this definition. Like for a uniform meter rule, once the meter rule is uniform, the center of gravity is at the midpoint. So assuming you are solving a problem, like a problem on moments, and the question says a uniform meter rule, you should know, once you hear that word uniform, it means that the center of gravity of that meter rule is at the center or at the midpoint of the meter rule. Then for a uniform circular plate, the center of gravity is at the center. The same thing for a uniform circular ring, it is also at the center. For a uniform square or rectangle, you draw diagonals. You draw diagonal so that at the point of intersection of the diagonals is where the center of gravity of a uniform square or rectangle is. Then also for a uniform triangle, you draw median. The point of intersection of the medians of the triangle gives you the point or the center of gravity of the triangle. So you can actually use this to locate the center of gravity of different shapes, but they must be regular shapes, right? They must be regular shapes. So this is the center of gravity for some regular shapes. Okay, so we are going to look at stability of some objects. Okay, so when we're talking about stable equilibrium, what that means that the body will tend to return to its original position when it is slightly displaced. So a body is said to be in a state of stable equilibrium if it tends to return to its original position when slightly displaced. E.g., a body with a low center of gravity and with a wide base will be in a stable equilibrium. So if you look at some object like, if you look at some equipment like a racing car, if you see a racing car, you find out that the car is very low. Yes, the car is low and the base is very wide. So that because they use it for racing, so that it does not easily topple over. So they make the center of gravity to be very low. So, and that accounts for its stability on the ground. Is that okay? Also, a cone that is resting on its base. If a cone is resting on the base, like in this particular diagram, if you tilt it a little bit, it will return back to its original position. Also, a ball that is inside the middle of a bowl, if you displace the ball, it will return back to its position. If you display it to this direction, it will also return back to its original position. So these are examples of stable equilibrium. And please, I want you to take note of all this, right? Please take note of them. These are basically objective questions that you can have or you can see. Okay, so these are examples of stable equilibrium. Okay, so a body is in a stable equilibrium. When it is displaced slightly, it will return back to its original position. Okay, so we'll look at another equilibrium state, that is unstable equilibrium. A body is said to be in an unstable equilibrium if, when slightly displaced, it tends to move further away from its original position. Right? Okay, so if you look at like this cone now, if you displace this cone slightly, it will definitely move further than where it was in. So like this cone, we say that it has high center of gravity and a very narrow base. Look at the base, very narrow. So once you displace it a little, it will tend to move further. So a cone on its apex or pointed end is an example of a body that is in an unstable equilibrium. Also, a ball resting on an inverted bowl, like this ball. Now, if you displace this ball slightly, it will roll over and fall down. Okay, it will roll over and then fall down. So these are examples of unstable equilibrium, right? Those are examples of stable equilibrium. Okay, so these are neutral equilibrium. A body is said to be in a neutral equilibrium if, when slightly displaced, it tends to come to rest in its new position. Here, the center of gravity remains unchanged. So a cone that is lying on its side is an example of a body that is in a state of a neutral equilibrium, right? Then a ball that is resting on a horizontal floor is also in a state of neutral equilibrium. Then a pipe that is also resting on the side is also in a state of neutral equilibrium. In all these instances, the center of gravity remains unchanged. Okay, so even if you roll this ball, it will just be rolling like that. If you roll this cone, it will roll just like that. Then the same thing with this. All right, so these are examples of stable or neutral equilibrium. So for this particular class, we have discussed a torque, we have discussed a couple. We said that a couple is equal and opposite forces that causes a turning effect, and the turning effect of a couple is called a torque, right? Or the moment of a couple is called a torque. Then we talk about stability of objects. The most stable objects are objects that have low base or low center of gravity and wide base. So we discussed that, we talk about unstable equilibrium, high base and high center of gravity, then neutral equilibrium. Okay, so guys, this is where we are going to stop for our class for today. But before we leave, please, if you have not subscribed to our channel, please subscribe to this channel, click on the notification bell so that YouTube will always notify you when we upload a new video. This is Nobleman Science Tutors Online. We are bringing physics direct to your very doorstep. So you can reach us through the WhatsApp number showing on your screen. And also, if you have any issue or any problem on physics, you can communicate with us via the WhatsApp number. So thank you so much for your time. We hope to see you in our next class. Thanks.